values of m starting from 0 will be having y1 on the left side, y0, y0 h minus 2x0 over y0 minus 2x0 plus h whole divided by y0 h times y0 minus 2x0 over m. Okay, now you can see on the right side we need of x0, y0 as well as h. So all these three are available. X0, y0 is here and h is here. We can substitute into this and simplifying. The remaining you can do it by using your calculating devices. The ultimate result you will be getting is 1.0959090. The second requirement for putting m equals to 1 is y2, y1 plus h by 2, y1 plus h, y1 minus 2x1 over y1 minus 2x1 plus h. I'm replacing just the index by 1, so this takes the form y1 plus h into y1 into x1 over y. This is 0 here. 1. Okay. After doing this, you can see on the right side we require x1, y1 and h. And all these three are available. x1 is 0.1, h is 0.2, 0.1 again, and y1 we have just calculated. So bringing these values in this side and using your calculating devices and simplifying will give you the answer 1.18409759, whatever it is. So these are the two results you have to note down. Two results we have obtained for the Euler's method and two we obtained for the modified Euler's method, improved Euler's method. Now lastly we are going to apply the third method of the modified Euler's method. Okay. First of all, as usual, you will be writing the formula for the modified Euler's method, and the formula for the modified we have derived in our today's talk. Ym plus 1 is equals to ym plus h times f of xm plus h ym plus h by 2 and f of xm and ym. So this is the modified Euler's methods formula. Take start the recursive relation from putting m equals to 0. This gives you y1 on the left side, y0 plus h, x0 plus h. Before putting the values, why don't we put the functions in? If you substitute the function and replace this function by this quantity, the inner function, and after putting this, you have to replace the outer function, and you will be getting the recursive relation of the form ym plus h. Inside there will be ym plus h by 2, ym minus 2xm over ym. We 2 into xm minus h by 2 whole divided by ym plus h by 2 ym minus 2xm over ym. So here I have replaced the inner function with this and then the outer function, and we got this recursive relation. Now you can put m equals to 0 will give you y1, y0, h, y0, h by 2, y0, 0 here everywhere, and 2 times x0 minus h by 2 whole divided by y0, h by 2, y0 and x0 and y0. and we are given the values of x0 and y0 as well as of h. So put these values in this part of the equation, and simplifying will give you a result of the form 1.09547619. So this is the first requirement which we got by using the modified Euler's method. And similarly, by putting m equals to 1, the second recursive relation takes the form y1 plus h times y1, h by 2, everywhere I am replacing m by 1. y1 minus 2x1 over y1 minus 2 times x1 h by 2 over y1 plus h by 2 y1 minus 2x1 over y1. So this is the second recursive formation after putting m equals to 1. Now we have the values of y1 and x1. y1 is this one, x1 is 0.1, h is 0.1. So put in the values and simplify. You will be getting the result 1.17535468. So this is the result you will be obtaining after the simple calculations. So we got the three results for the three methods. Now we also have the exact solution of this differential equation, which is generally provided, or you can solve this equation very easily, and you can get the exact solution of this equation is y is equals to 1 plus 2x square root. This is the exact solution. Now we can find the approximated value at the two locations of x1 and x2 for the exact solution, so that we can make the comparison with the approximate solution. So here, whenever we approximate it, this is the exact solution I am taking here. The exact solution is y is equals to 1 plus 2x. If I introduce the index here, ym, so m putting 1 or 0 you can put, m1 is giving you y1, 1 plus 2x1 because we are looking for y1. So x1 is 0.1, so 1 plus 2 into 0.1, this gives you 1.09545. And the second requirement was, if you remember, on putting 2, we get y2, 1 plus 2 into x2, and x2 is 0.2, so this gives you 1 plus 2 times 0.2. So the net result is 1.18322. So this is the result, which is the exact solution at the two locations of x1, which was 0.1, and x2, which is 0.2. Now we can summarize the whole result. If we summarize the whole result for the x values, the Euler's values, improved Euler's method, modified Euler's method, and the exact solution, as we have done before this in the previous example. So here we have to calculate the value at 0.1 and 0.2. Euler method gave you the answer of 1.1 and 1.191818. Improved Euler's gave you the answer 1.09 590909, 1.18 4097. Modified gives you the answer 1.09547161, 1.17533546, and the exact solution. These are the exact solution: 1.09545 and 1.18322. Now you can make the comparison. So here we again see the modified and the improved method are giving you the better answer comparatively to this one. So ultimately we came to the conclusion that the improved Euler's method and the modified Euler's method are slightly better as compared to the simple Euler's method. Hopefully you learn all the steps behind these three techniques, and there are many questions available in literature, different books. Through different books you can solve them just to do practice and learn and get grip on these three methods. So with this, thank you very much, and Assalamu alaikum.